Next is to give you some idea what the code can do to predict something, generally not conventional. For instance, predict the flow near the end wall due to an inlet boundary layer profile. If you are not really in the turbo machinery, you probably can appreciate. If you walk to a tall building, okay, where very windy days, if you stand in a corner, you see one side of a building, the leaves spiraling around in the corner. And what's this all about? Those are nothing but. It's because Earth's boundary layer create a profile, and that profile result in a large radial migration, create a vortex in the corner regions. And this example is really to show you, if your boundary layer come into the cascade environment, the three-dimensional environment, near the end wall, near the ground, what we can call it, the flow field is somewhat different from the misband. And nowadays, all the effort put it in, people want to Endwall contouring to minimize the loss associated with inlet boundary layer, the flow deficiency near the wall area. So what I'm going to show you here is, here we'll be able to predict the flow field very accurately near the end regions. With this reliable prediction, you'll be able to rely on it to do improvement, to do Endwall contouring, to go forward. But this phenomenon is not unique. You can see on daily life. It depends how you interpret the phenomena. Right? So here we show both the measured pressure on the Endwall and versus predicted pressure on the Endwall, and measured the friction on the Endwall versus predict friction on the Endwall. So you'll be able to know where the loss come from, how the whole thing interact.